Hello student, today we will discuss about dehydration of 1 degree, 2 degree, 3 degree alcohol by PO Cl3 and pyridine. Question is, what happens when isopropyl alcohol reacts with PO Cl3 in presence of pyridine? And second is, ethanol reacts with PO Cl3 in presence of pyridine. Write down reaction mechanism and intermediate formed in it, and draw this structure also, and the action of PO Cl3 in pyridine at 0 degree C. What will be the product, and on heating what will be the product. Both the products are different, so that you should know about it, that it is a temperature dependent property. Now E2 elimination occur in this case. We will discuss that later on. Dehydrating agents used for alcohol, dehydrating agent used for acid and acid amide. Here I will give answer for this. Acid carboxylic acid are used in presence of this P4O10. It will convert it into acid anhydride, and acid amides in case presence of P4O10, it will convert it into alkyl cyanide. P4O10 I will write down. In both the cases we are using this phosphorus pentoxide. Okay, P4O10. I will let you know about this on the later on also. So P4O10, what is the function of P4O10? It dehydrates acid as well as amides. Right, now we'll go for the first question. See here, isopropyl alcohol I have written, and then this POCl3 pyridine, then propene elimination E2 reaction occurs. Means product of isopropyl alcohol after dehydration, it will produces propene. So what will happen? First adduct is formed. In the oxygen and phosphorus is they are having more affinity as compared to PCl bond. Okay, that is why OP bond is stronger. So PCl bond, this Cl is cleaved and this is kicked out, because it is having affinity, phosphorus having affinity with oxygen. Okay, so we'll get this protonated chloroester, dichloroester it is. So this is better leaving group. You know, OH group is a very poor leaving group, and that is why we have to use conc H2SO4 for dehydration of it. But in this case, when we are using POCl3, a bulky leaving group is obtained, and which is cleaved very easily even in 0 degree centigrade. Clear to you? So it is very safe and useful reaction, although it is not given in the textbooks. But what they are doing, they are giving you this so that they can find out the excellent category of students. Okay, you have learned up till this stage. Okay, otherwise they are giving PCl3. So PCl3, when they are using PCl3, you will get alkyl halide. You will not get propene by this. Okay, so only this will give you at 0 degree C propene. Clear? Now see, this protonated chloroester phosphate ester will be added to is formed here. After that, this oxygen will not carry positive charge for a long period of time, because it is electronegative. So cleavage occurs and this is kicked out. This leaving group is better leaving group, so it will be kicked out and formation of carbocation takes place. Okay, and after that pyridine grabs the proton and will get propene. Here I have written how. You see here I have made this CH3, here one positive charge I have to show. Okay, so this is carbocation, alpha hydrogen can be grabbed by the pyridine and will get propene. Okay, so elimination occurs, result propene. So this is E2 elimination. Clear to you? Now here I will show you what is this. See why it is going to happen, why we are using POCl3. See, this chlorophosphate ester will get chlorophosphate ester. Clear? This is and that is I was saying you that it is a better leaving group, right? Now that I told you also, OP bond is stronger. OP bond is stronger than I have not written. So then PCl bond. Here I am writing. Then PCl bond. So that is why PCl bond breaks away and Cl negative is kicked out. Clear? Break up PCl bond. This is weaker. I will write on here, weaker. Okay, break up PCl bond, and so then bulky chlorophosphate group is added, and then it will be taking away. It will get protonated. I told you that it is getting protonated over here, so it is kicked out. Okay, and then I have written this, that this PO Cl3 is obtained. This ester. Here I have written the chlorophosphate ester, because in one page we cannot put everything. That is why I have given you description in the, see here. Then bulky chloroester phosphate group I told you, and base, that is pyridine, grab the H positive and we'll get alkene. So direct alcohols are converted into alkene in this case, and according to Sched's rule it occurs always, and trans alkene is preferred over cis alkene. Sometimes they are giving, in MCQ they are giving the cis 2-butene or trans 2-butene, like this type of question they will ask. At that moment you have to select trans, okay, because trans is the major product in this case. Now we'll go for the another question. This write on yourself, CH3CH2OH, POCl3, okay. I think you are expert now. CH3CH2OH, I add POCl3 into it. This O lone pair of electron coming to P, forming PO bond, and PCl bond weaker, so cleaved. Cl will be cleaved. Here Cl is kicked out, and then we'll get protonated this ester, because this is attached with this. So, and OH group is also present, and this oxygen is getting, it is giving lone pair of electron. That is why it is having positive charge, because 3 bonds cannot be present in this oxygen atom. So after that it will be cleaved. So we will get this dichloroester. Okay, we'll got in chlorophosphate ester, I told you separately. Okay, then we'll get carbocation, and then this pyridine deprotonates this carbocation and giving you alkene. So now next question was dehydration of ethanol by POCl3, product formed is ethene. Now dehydrating agent used for alcohol, so many. I have given you list: POCl3, Conc2SO4. Now what is POCl3? This is phosphorus oxychloride. Okay. Conc2SO4, Al2O3, H3PO4, KHSO4, POCl3, etc. Anhydrous ZnCl2 also I have given that in Lucas test it is required. Its requirement is must, otherwise will not get turbidity. The reaction will be in equilibrium. Okay, this anhydrous ZnCl2 removes water formed in the reaction. For acid and acid amide dehydrating agent, which dehydrating agent is used? P4O10, that is phosphorus pentoxide. So acid in presence of P4O10 are converted into acid anhydride, and amides are converted into RCN, nitrile group. Okay, next we have to go for this. Draw this structure first. Draw this structure, and we have to write down POCl3 0 degree C at pyridine, means in presence of pyridine. And POCl3 I have written here. Then 2 reagents we are using, and I am telling you the reaction means role of each. When POCl3, what POCl3 does, it removes OH, forming adduct with POCl3. Okay, and the bulky group is kicked out, forming a carbocation. So the main purpose of POCl3 is to form carbocation. First of all, adduct is formed, and then this carbocation is obtained. So this is adduct. We can say it adduct. Right? Now after this oxygen will not carry positive charge for a long period of time, so it will be kicked out, and we will get this chloroester. Okay, now we will get carbocation, because everything is cleaved, only we have got this. And then at 0 degree C, normal means H from here will be deprotonation will occur, because pyridine is here, so alpha hydrogen is removed from here. Here I am writing H. So this H is coming to here, pyridine. Okay, so it is cleaved, so double bond is formed here in between these two. Clear to you? At 0 degree C. But pyridine, when we are heating at high temperature, the rearrangement occurs. This is 2 degree carbocation. If 1,2 hydride shift will be there, hydride shift is coming here, H negative shift. H negative hydride shift will be there. Okay, so this hydride is shift over here. So what will happen? We'll get 3 degree carbocation. Is that clear to you? And now this and this rearrangement is taking place in high temperature, that is I am telling you. And at high temperature again we'll get two products. H from there will be kicked out, or H from here it can be kicked out. But here when we are kicking it out, so we'll get this type of alkene. And if we will get this hydrogen is kicked out, we are getting this type of alkene. So in this case, highly substituted alkene, that is why it is major and it is minor. It is 1, 2, 3 tri-substituted in most of the cases. Here 1, 2, 3, yeah, almost means a little bit difference between them, marginal difference between them, right? So this type of alkene will be getting over here. Clear to you? Here because one H is there, so it is a little more. This will be little more as compared to this. Clear? This is all for you, and all the best. I think that I will repeat this so that there will be no confusion. This is bulky group. This OH group will take POCl3 bond form between P and O, and rest of the thing all you have to write on as it is. And then simply OH and phenol is also you have to write on here, and at that moment you have to write on E and this together, because we are showing that this is going to take place and this is kicked out. And then when it is kicked out, the Cl negative, then we'll get this protonated ester. We'll get protonated ester, and after the leaving of this group, bulky group, we'll get carbocation. Main aim of us is to form carbocation, and then pyridine will get the proton from here, and we'll get alkene at 0 degree C. There will be no rearrangement, but on heating, Wagner-Merven rearrangement occurs, and we'll get this alkene. Two types of alkene, and one is major and second is minor. In both the cases, here from here H can be removed. See here H or here H. Okay, so if this H is removed, we'll get this alkene. This will be major, and if H will be removed from here, so we'll get minor. So from any place, because both of them are alpha to this carbocation, positive charge. Clear to you? That's all for you. All the best. God bless you. Bless you all.